This is Quick Clip 2.13, Physical and Chemical Changes. First, let's take a look at an example of a chemical change, in this case oxidation or the rusting of iron. At the top we see the chemical formula, and we see that we start off with 4 atoms of iron, or the symbol Fe, and we react that with 3 molecules of oxygen, or O2, and then along with the energy from the sun, we end up with a product of iron oxide, 2 molecules of iron oxide. And then above it we can see some pictures of the before and after. So on the left we see the iron chain, and then on the right we see the rusted iron chain. Below that we see symbols of the atoms and molecules involved. So we see the 4 iron atoms and the 3 oxygen molecules. Those atoms break apart, and during the reaction they reform into 2 molecules of iron oxide. So on the left, the molecules that are reacting together, those are the reactants, and then on the right, the material that is produced is called the products. In the lesson, they also talk about nuclear fusion, and here's an example of 2 hydrogen isotopes, H2, which is called deuterium with a mass of 2, H3 has a mass of 3, and that's called tritium. In nuclear fusion, under a tremendous amount of heat and pressure, the hydrogen isotopes are going to collide, and they fuse together, resulting in an atom of helium, and then the release of a neutron, and then also a tremendous amount of energy is produced. So here it's important to note that chemical reactions will pretty much always either involve an absorption of energy or a release of energy. So in our first example, the sun's energy went into the reaction. In this example, energy is being released from the reaction itself. Other signs of a chemical change would include whether or not bubbles appear. That would be a signal that a gas has been created. If a solid forms, if there's a change in temperature, if light is produced, and also if there is a color change of the material. Other examples of chemical changes include digesting, burning, decomposing, explosions like you would see in fireworks, or again, rusting. Now here we have an example of physical changes where folding, cutting, or crumpling paper is a physical change and nothing new is created. The substance stays the same even though the appearance may change. And again, here's another example where a state of matter would be considered a physical change because no new substance is formed. There's no chemical reaction. So if this is a piece of metal as a solid, and then we heat up that metal and we melt that down, then it becomes a liquid, but those atoms are still the same atoms. It's not combined with other atoms. The material that it started is still the same material that we end with. And then examples of physical changes would include bending or folding of the material, freezing or melting it, cutting it up, or boiling it. In all of those cases, the molecules remain the same. All right, there's no change, there's no new substance. Now here's an example of a candle burning, and it's an example of both a part of it is a physical change and part of it is also a chemical change. I'm wondering if you can determine what part of that picture is the chemical change and what part is the physical change. Take a moment, maybe pause the video and think about it. Alright, so the answer would be that the wick that burns is undergoing a chemical change. So if you remember, burning is an example, or flammability is an example of a chemical property, and the burning of it is a chemical change. So that wick is burning, and it's not going to be that same wick anymore. It's going to be turned to ash. And then the part that is a physical change is the wax that melts. And so the melted wax, it would no longer be a solid. It's melting down to a liquid, but the wax is still wax. It's just in a different state of matter. So this would be an instance of both a physical and a chemical change.